My name is Zeljko. At first, thank you all for coming to my presentation. And in the next couple of minutes, we'll be talking about best advices, approaches, suggestions, common pitfalls and problems while developing white label systems for Android mobile phones. It's a really interesting topic for me. I've been mostly focused on white label systems for the last couple of years, and I really hope that you'll learn something new. Just for starters, a few notes about my company. So I work at Infinum. We are an independent software development and design agency with headquarters in Croatia. We've been involved in mobile development for almost, I would say, 7 years now. And that time we have developed, I would say, somewhere around 75 to 100 different Android apps. Okay, enough about Infinum. Let's start talking about white label systems. Okay, so at first, just quick show of hands. How many of you here actually know what the white label system is and have maybe done some work with it? Okay. So for those who don't know, white label system or a product is a product or a service produced by one company that other companies rebrand and make it appear as if they had made it. This is a definition from Wikipedia. It's okay, but let's try to describe it with more, I would say, common words. So basically, a white label system is a system which is produced by you as a software company. And then that system horizontally scales because you're selling basically your app to your customers. They buy the code from you, they rebrand it, so they just like change the colors, icons, assets, and stuff like that. Maybe make some customizations to code, like customizing business logic or navigation flows or something like that. And then they publish it to production by some way of production channel. And the most important thing about white label systems is that all of the apps which are a part of white label system have a contract between them that most of the functionalities and features should be the same and should work in the same way. So basically in white label systems, we're actually targeting around, I would say, 90 to 95% of code sharing between all of the apps. And we just offer our customers with limited customizations, like UI or something like that. For a simple example, this is an example white label system on which I was working. I think that was 3 years ago. It's a theme park white label system for a company which owns a large number of theme parks throughout the world. And basically, we had a white label system, which means that we had one system with one set of features and functionalities, and we just produce a different, separate applications for each of the parks, which was a part of that theme park company. So as you can see, the functionalities are the same. So we have some maps, some filtering options, and stuff like that. But the apps have different UI, like colors. You can see that the icons are different, a map is different. So basically, each app adheres to the brand guidelines and brand standards for that park. So what are the advantages of a white label system? So basically, I would say that the most important advantage is that you are outsourcing your development needs your development to a trusted third-party company, which should provide you with some level of expertise because they have already solved all of the problems which you will stumble upon while developing an app by yourself. And also, white label system actually provides your brand with a refined product, which means that you can download and check some other application which is a part of that white label system from Google Play or some other means of production channel before you actually buy it by yourself. So you can test it, you know what you are getting for your money, you can check what are the problems, what are the features and stuff like that. So basically you know what you are getting before you actually buy anything. And all of this in the end results with saving time and money, which is really important, especially for, smaller startups or stuff like that. But also there are there are disadvantages. I would say that the most important disadvantage is actually the lack of control. Because as you have outsourced your development to some third-party company, they're now in charge of your development process. So basically, they will say what will get released in the next versions, what will be fixed, what new features will be included in the next version. So basically, they are in charge of that development. If you are like a big customer for them, and if you have a lot of money, maybe you can influence on that development roadmap. But in most cases, they will ignore you and they will continue the development on their own. Also, the big problem is that, as already said, so basically there is a contract between all of the apps which are in a white label system, and this forbids you to implement a more complicated level of customization in your apps. So basically, in most cases, we offer a limited customization, only, I would say mostly resources, but we tend to forbid the customization which should be implemented on navigation flows or business logic and stuff like that. So something that's more complicated. And from marketing standpoint, there is a problem that all of the apps have a unified product vision. So basically, all of the apps work in a pretty much the same way. They offer the same functionalities. And your customers will have a hard time in becoming loyal to you, to your app, because there are a lot of other apps which basically do the same thing that you want to solve. So, how to build white label apps for Android mobile phones? This is the question which we'll be trying to answer in the next couple of minutes. And at first, let's go a little bit back to the memory lane, a few years back in the past. And the answer to that question was really quite simple. Basically, it was just pure magic. If you were involved in Android development 5 years ago or 4 years ago, that moment we didn't have well-defined architectural patterns like MVP or MVVN, which were proven to work okay on Android. We didn't have tests. We didn't have dependency injection. It was extremely hard to offer some kind of customization. We were still working in Eclipse, and it was a really painful time. But with all the changes in the last couple of years, with, new architectural patterns, frameworks, libraries, and stuff like that, today the answer for that question is really quite simple. Today, if you want to develop a white label system, you just have to carefully design the system, all of the puzzles which will in the end consist and build your system. In my own experience, I would say that there is currently just one prerequisite in developing white label systems, and that is that you don't use fat clients. You don't use fat client type of architecture. So, quick raise of hands. How many of you here knows what a fat client type of architecture actually is? Okay. For those who don't know, so a fat client is a type of server-client architecture where most of the heavy work is actually done on the client, on the mobile phone. We usually tend to do this if you would like to offer full offline support or stuff like that. But basically, this is really a problem in white label systems because this has an enormous effect on the level of customization which you offer to your customers. Every time when you want to fix something or when you want to introduce a new feature, you have to release a new app version. So if something like breaks or something is not working okay with your business logic, you fix it and you have to force your users to update it so that they get the bug fix to their code. It's extremely prone to errors and it's really hard to maintain. That's why in most cases we tend to use a thin client type of architecture, which most of the heavy work is actually done on the server, and server actually configures the application so that it can work by itself. And the funny thing is that most of the systems actually fail on this point. If we go a few slides back, so I told you that I was working on a white label system for theme park company. Actually, that started as a single application for a single park. And our customer demanded from us that we offer full offline support because there's a possibility that there will be a flaky network connection in the park. And we implemented that app in, I don't know, like, I would say 5 or 6 months, released it to production. And it was a huge success. And 1 month later, our customer had a new feature request from us. He wanted to horizontally scale the system and release that app to, I would say, 7 or 8 parks. All of the apps should have the same UI, but they should have different brand guidelines, so different colors, assets, text, and stuff like that. And some features had to be enabled and disabled for few parks. And that was actually a big problem for us because we didn't plan the architecture in that way. And I still remember when I asked my boss, like, what do we do now? We just released an app to production, and we need to take another 3 or 4 months to refactor the app in order to make it horizontally scalable. It was quite an enormous task to refactor it, but we managed to do this, I would say, in 3 months. And afterwards, our system could horizontally scale to 1,000, 2,000 million different apps. Okay, let's talk a little bit about system architecture of those kind of apps. So Gradle actually offers you 2 well-defined architectural principles or components, how do we call it? Basically, you can divide your apps in flavors and modules. And the same thing adheres to white label systems. But each type of that, let's say, architecture has its own advantages and disadvantages, its own limitations, and which are like important for white label systems. So let's start with flavor architecture. So in flavor architecture, we actually have a main flavor, and then we have product flavors. So we all know how does this look like. And from white label system, point of view, main flavor actually should contain the shared code, so the shared functionalities which are the same for all of the products in your white label system, and it should only contain default set of resources. So the resources which will not change never between the products in your white label system. And then each product flavor is actually an application in your white label system. It should be as minimal as possible. It should contain only product-specific code, like if you want to offer some level of customization. And it should hold only product-specific resources. The advantages of this architecture is that this type of white label system is extremely easy to maintain and develop, and you will quickly develop all of the functionalities. Mostly we work in main module, in main flavor, sorry, and every time when we want to offer some kind of customization, we switch the product module to product flavor and implement that custom behavior which we need to do. It's really easy to configure, so basically you just have to add another product flavor in your build Gradle file, generate a key store, and you're all ready to go. But there are also big disadvantages. I would say the most important is that the customization is extremely hard because the code is tightly coupled between the main flavor and the product flavor because you get the build variant. And as you will be offering your customers with more complex level of customization, you will quickly get an exponential increase of files and resources because you will have to add custom resources in each of the product flavor. The second type of architecture is when you use modules. So basically you have a main module and you have a product module. This type of architecture, each product module is an app by itself, and it has an external dependency to the main module. So there are no dependencies between the apps in your white label system, just a dependency to the main module. The same principles adhere. So basically, main module should only contain a default set of core functionalities and default set of resources, and each product model is then a separate app which has a dependency to main module so that you can reuse the components and features which were defined in it. The advantages of this kind of architecture is that it's extremely easy to customize because you can use the default implementation from main module, or you can provide a product-specific implementation in that product module. The awesome thing is that the apps are completely isolated between themselves. So basically, you can have a team of Android developers working on one product, another team on different product, because there is no dependency to main module. But the disadvantages are that it's really hard to maintain, because in most cases, when you will be implementing some feature, you will have to copy the code between the modules, maybe cherry pick the commits. And the important thing is that you can easily lose focus when you are developing a white label system with this type of architecture. With this, I mean that as you're offering your customers with a more complex level of customization, your app can quickly start to diverge from the unified product vision. So basically, you will be offering your customers with such a big level of customization that it will start to break the contract between other between other apps which are in a white label system. And that's basically not what the white label system is. If your app is just using some core features like authentication layer or network layer or caching layer, and everything else is customized, then this is not the white label system. You actually have some common SDK or common library which holds this default set of functionalities, and you reuse them in all of the other apps. So it's really important to stay on the right track and not to lose focus when you're developing those kind of apps. And from the architectural point of view, it's also really important to start grouping functionalities into features. So in white label system, each functionality should be a feature. So it should be in its, let's say, separate package. With this type of organizing your files, each feature has a single point of entry which you actually control. So basically, you can either allow some modification, you can allow some customization, you can forbid it. Basically, you're in a full control in which type your user or your client is accessing that feature. What's even more important, if you group functionalities into features, they can be easily enabled and disabled. And that's really important because of the pricing module which you offer to your customers. So in most cases, white label systems offer a large set of functionalities, like, I don't know, you offer 50 or 100 functionalities or features to your users, but not all of the customers want to have all of the features. So you can easily disable features which were not bought by your customer in their app and enable all of the features for some other users. And they can be extremely easily customized because you know that everything what actually describes a feature or a functionality is bundled in that package, and then you know what do you have to customize in order to what you have to modify in order to get the full customization. And also, if you group functionalities into feature, you can mark some functionalities as open or closed. So for some functionalities like network layer or authentication layer, caching layer, something like that, it's really not important that you offer customization to your users. Like if you have a network layer, it's really not important that for some apps you use, let's say, retrofit for API calls, and for other apps you use volley. That's really not important. So basically you can mark that feature, like networking layer, as closed, and you forbid the customization. But maybe for other features you would like to offer some level of customization, and then you mark it as open. Okay, moving on. So it's extremely easy to achieve that all of the apps work in the same way. So basically you just add a new flavor, generate a key store, add new resources, and that's it. But the tricky part and the fun part is when you have to start providing your users with some level of customization. So we will now take a closer look into a few different principles with which we can achieve that functionality. So the first thing, and probably the most, I would say the easier thing, is that you use a build configuration file. So basically each value which you want to customize per different apps, you extract them to a Gradle file and mark them as a constant. And the only thing that, so basically, and then when you want to access that value, you just access it by the constant key which is defined. For example, let's say that I have a Whitelabel system which offers 2 different apps. The first one is called white app, the second one is called the blue app. And each of the application has its own API URL. It has its own URL schema and own Google Analytics ID. I have extracted those values to build configuration, to build Gradle file, and the key is the same, but the values change. And then when I have to access those values, I access them by the key constant from the build config file, which is actually generated every time when you switch between build variants. So this is a really simple example how can you customize something in your apps. And for bonus, you can also customize resources, which is extremely important when you have to customize something what either needs to have your application ID or some hashes or something like that. So basically, you can add to your resource folder from the build Gradle file basically pretty much everything what you want, anything you want. Okay, the next thing is configuration file. So build config file is okay, but you can't offer your customers with some, let's say, more complex or modular customization, and for that we use configuration files. So configuration files can be either locally cached or obtained from the API, and they are used to customize your application on the fly. So that can be some, I don't know, XML file, JSON file. It can be an API response which is obtained on the app startup. Basically, it's just some Java class or file or something which you use to customize the application. As I said before, it's more flexible than build config file because it offers you a little more modularity. And the rule of thumb here is that you have to use descriptive method naming for all of the features which you want to customize. But more about this a few slides later. And with configuration file, you can easily customize your application on the fly. So basically, you can either enable or disable features. Maybe you can change the data flow, update the screen flow, pretty much anything what you want. For example, let's say that I have defined an app configuration interface, which will customize the apps in my Whitelabel system in a way that I can either mark social login as enabled or disabled, or I can return the list of menu items which will be used in navigation drawer for the logged in users. And then I provide the implementation of that interface per each of the app in my system, or a default implementation. And I can say for the configuration which is used in white application that the social login is disabled, and for some other application I can mark it as enabled. And then with dependency injection, I just implement the correct implementation for each of the app in my system. Regarding descriptive method naming, so when you're writing a configuration file, you should never use your application names for your method naming or variable naming, because your system can easily horizontally scale. And at first you will ask yourself, okay, am I in application A or in application B? And regarding on that, you will customize your data flow. But once when you have 1,000 apps or 1,000,000 apps, it can be a little bit tricky. So basically, you have to use a descriptive method naming, which just defines the behavior which you want to customize. The next important thing is that you start to programming to interfaces, because as you already seen before, with switching the implementation, we can easily achieve the customization. So every time when you have some functionality or a feature, extract it to an interface. Every time when you want to integrate with external dependency, extract it to the interface. Because if everything is defined with interfaces, then you can easily switch between the implementations. For example, let's say that I have an interface which is used for loading the images into image views in my app. And with providing the correct implementation, I can either use Glide Image Loader, or I can switch to the default implementation, which is used with Picasso. And I can switch between those two types of image loader implementations by some property which was defined in configuration file. And this is extremely important and extremely easy. This is actually a problem which we've occurred, which we stumbled upon, I don't know, it was 2 or 3 years ago, because we had to switch between different image loader libraries in our app due to licenses and some other things. So a few of our customers wanted to use Picasso, a few of them wanted to use Glide, few of them wanted to use Android, I think it was called Universal Image Loader. And by extracting that to an interface, you can easily switch the correct implementation. Also, you can provide, if you're using flavor-specific type of architecture, you can switch between the versions of a same library which is included in your app. This is something that you mostly don't want to do, but it's extremely easy, and it's really good when you have to do it. So basically you can provide, I don't know, for white application you can include Glide version 3.6.1, and for blue application you can use version of Glide 3.5.0. We've also had problems with that. So basically, as we were working on that theme park application, we had an external company which provided us with a library for user location detection in the park, because they've used Bluetooth beacons for that. And for some reasons unknown, we were actually getting different versions of that library for each of the park which was a part of our white label system. So we get the versions, I don't know, we get the version 2.5.0 for a smaller subset of parks, version 2.4.9 for some other parts of park, and with this we can easily switch between the correct versions for the apps which we wanted to customize. Okay, that was a little bit theory. Now let's move to a little bit more practical examples. So at first, let's say that we want to offer our customer with some level of customization. We just want to customize resources for each product which is a part of white label system. And how to achieve this? Well, this is really easy. So basically we have different flavors. We have default resources in main flavor and product-specific resources in product flavors. We just need to have the same key. So this is pretty much simple. But what if our users want to have custom business logic? So maybe they want to, I don't know, use some other type of validation, or maybe they want to switch some part of business logic or stuff like that. This is also really simple and easy. If you're using some well-defined architectural pattern like MVP, you have already extracted the business logic to a presenter, and then you just provide the correct implementation of that presenter by dependency injection for each product which is a part of your app. So pretty much simple. For a complicated case, let's say that our users want to have a custom business logic and a custom navigation. So, and to complicate things even more, let's say that we want to have a default and a product-specific behavior. And for that, we'll use a combination of interfaces, features, and configuration file. So this probably looks a little bit complicated, but it actually isn't. So let's say that we have a feature inside of our white label system which offers a navigation from point A to point B to our user. And you want to use a default implementation of that navigation for 90 apps in our white label system, and we want to customize that flow only for, I don't know, 5 apps. Okay, so at first, we extract the navigation functionality to an interface. We define a method which will like create a trip for from some activities to some other activity. Then we create a different interface which will define the behavior of the navigation for that specific use case. Okay? Then we provide a default implementation of navigation interface, which is used for all of the apps in our white label system. And this interface receives navigation behavior interface as its constructor implementation, which is provided with dependency injection. And in create trip method, it just proxies the that behavior to navigation behavior. And then with providing different implementations of navigation behavior interface, we can easily switch between the desired navigation flow for our apps. So let's say that for default navigation behavior, we want to navigate the user to some create trip activity, which is a part of our white label system. Let's say that for a smaller subset of our apps, we provide some different navigation behavior, which will navigate the user to Google Maps. So basically, he will leave our system. And for a tiny, small proportion, tiny, small set, let's say that we want to use WebView or Chrome custom tabs for navigating the user. And then easily, just by switching the implementation which is provided in the constructor, we can change the behavior and data flow for apps in our system. And what's even more funny and what's even more important, we can also provide different implementation of the navigation interface. Basically, for some apps, we can provide a different implementation which will not use any of it, and we can customize it by any ways, by any means we want. Okay, but as you're developing a white label system, if you offer more complex level of customization to your users, you will quickly start to get this type of feature requests from them. So basically, they want to customize a navigation flow or data flow in their app, but they want to keep the same functionalities, but they want to like use some of their own components, but they will still like that it works the same way as it works in the other apps. So basically, they want the same feature, but it should work completely different. But the thing is that in white label systems, when too much customization is needed for one app, which is a part of the system, the product vision starts to change. So as I said before, all of the apps in the system have a contract which states that most of the functionalities should be the same, most of the code should be the same. We just offer customization in a matter of, I don't know, some resources, something like that. But if you want to offer an extended level of customization, the product vision for that app starts to change and it starts to deteriorate from the unified product vision which your white label system is using. And at that moment, the contract between apps start to break. And the best thing is to cut the connections and extract that application from your system and release it to production on its own. So how to achieve this? In most cases, when we are developing white label systems, we actually start with the flavor-specific type of architecture because it's fast. Then when we have to offer some more complex customization, we refactor the code to a modular approach. And then as the customization needs starts to get bigger and bigger for a specific app, we start to cut the connections between that product module and the main module. So basically, we start to provide all of the shared functionalities in that product. And as we are removing the shared code between them, we can slowly start to cut the connections. And once we have implemented all of the functionalities and features by our own in that product, we can cut the connection and release it to production. In some cases, you still want to use some functionalities like, as I said before, maybe network layer or authentication layer because you use the same functionalities through your development process in all of the apps which you're developing. And for that, I would advise you that you extract that common functionalities to a library or some other module, so that both the app, which is now released to production on its own, and the white label system can have an external dependency to that shared module. Okay, and in the end, let's talk a little bit more about versioning of white label systems, because this is also a really important topic. So in Android, we mostly use semantic versioning for versioning the apps in our, which we are actually developing. And in semantic versioning, our version numbers actually consisted of 3 different parts. So we have a major, minor, and bug fix or patch number. And every time, and there are some rules how to increase numbers in semantic versioning. So if you have a patch update, this just means that you have, I don't know, resolved or fixed some stupid or small bug. Maybe you have added some smaller changes which will not break anything, which will not have any influence in any, like there's no possibility that anything will break. And when you make a patch update, you can release that update just to a specific application in your white label system. So there is no need for a system-wide update. If you have a minor update, so maybe you have introduced some simple new feature, maybe you have fixed something what is, once again, backward compatible, and this actually depends on the use case. So you can either go with product-specific updates and releases, or you can make a system-specific release. This really depends on the use case. And if you have made a major update, so maybe you have like redesigned your app, changed, I don't know, API provider, or you have implemented something that's not backward compatible, then you have to release the update to all of the apps which are part of white label system. This is based on my own experience, and that's something what we started to use after we got in such a huge mess with versioning of the apps which were in our white label system, because we had somewhere around 15 apps in production which had 10 different version names. We didn't know which version had something. We had to cherry pick a lot of commits between the versions, and it was really a big mess. We were really unhappy with it, and once we defined this type of updates, the things started to get a little bit better. But there is also one important thing what's missing here, and that is that Google Play currently doesn't offer you with a possibility to enforce a user update. So you can release an update to Google Play, but there is no way that you can forbid your users with using the application until it's updated to the latest version by default by Google Play. And for that, we have found a simple solution for that. We have implemented a client library for Android, which basically, with an API call, checks at the app startup if there is a new version available for that app. We can mark an update as optional or mandatory. If an update is optional, then we just show that information to our user with a dialog or push notification or something like that. But if an app is mandatory, if an update is mandatory, then we notify the user about it, and we actually forbid him from using the application until he updates the app. Okay, so to round up everything that I was talking about today, if you want to develop white label systems for Android, start with thin clients, because it will save a lot of problems with you in the later steps of the development process. Regularly plan your architecture and have regular architectural overviews and analysis of your system. If you see that the current architecture is not working okay with you, refactor it to something else. Don't wait until the app explodes. Start with a limited customization, and as your users will demand for the more complex customization, refactor your app in a way that you can offer them that. And if in the end, if some application in your white label system starts to deteriorate from that unified product vision, just extract it from the white label system and let it live on its own in the production. Okay, that's everything what I wanted to talk about today. I think that we still have some time for questions. So if you have anything, feel free to ask me now. Okay. If not, I'll be here for the rest of the day. You can find me in the hall or on Twitter or somewhere, and you can ask me anything you want. Okay, thank you.